Hi science students. In this video we're going to learn the scientific definition of work and how to calculate work done. Work in everyday English has all sorts of different meanings. You go to work to do your job. If you're doing schoolwork or homework, then you're doing work, for instance. Now, you need to learn the scientific definition of work. And it's a reasonably simple definition. It's the product of force and displacement. And by the product, we mean we multiply those. So you might push an object for a certain distance, so you're applying a force to that object, and you move it, and you cause a displacement for that object, then you are doing work on that object. I'll show you this animation just to illustrate. So here we've got the robot and the filing cabinet, and it's asking me to apply a force. So I'm going to push this object, okay, and I'm not doing work on it at the moment because the object is not moving. There must be a displacement. So that although the object, well, we're applying a force to the object, we're not doing work yet. I'm going to need to apply a greater force, okay, and now the object starts to move. I'm doing work on the object. And if I find the magnitude of that force and multiply it by the distance through which it's moved, or the displacement, then we can calculate the work that's been done on the object. Okay, so you can see that it's a fairly simple idea. So if you want to take some time to write that down, I didn't give you a chance earlier, you can pause the video and do that. Then I'm going to do some calculations. Okay, so a couple of calculations to do here. So the work done on a 30 kilogram object. So it's a force of 10 newtons is applied to this. 10 Newton force, and it moves 22 meters. Now it's interesting in this case that for our calculation, these are the important numbers. The mass is not important here. That might seem counterintuitive because you would say clearly, it's harder to push a 30 kilogram object than a 1 kilogram object. That's right. But that would actually just increase the force that you would need to apply. And so that would sort of come out and become evident from that perspective, that the force increases if the mass increases. You need to push with more force and hence do more work on the object. But for our calculation, not needed. So force is equal to, work is equal to force times displacement. So in this case, 10 newtons times 22 meters, so 220 joules of work is done. Right, so you saw in the definition that work is measured in joules. It's a unit of energy, and it's a scalar quantity, so no direction required there. Okay, we'll have a go at this one down below here. This one's a little bit trickier, all right? This is the one where a book is being raised vertically. All right, so the trick here is that you need to calculate the force that's required to lift this book, right? And the clue is that you're overcoming gravity. So what we're going to do is use force equals mass times acceleration. And then when we've done that, we can use that calculation to put our force into the equation here. Now look, this is a tricky one, but you might want to pause the video and have a dash at it first, and then I'll show you what to do. So go ahead and do that if you want to. Okay, so let's see what your answer compares to mine. So force equals mass times acceleration. So in this case, the force required to lift this book is equal to the mass of the book. That's 200 grams, but of course we need to convert that to kilograms, the standard unit. So 0.200 times acceleration. Now what on earth is the acceleration here? Well, there's the clue. What on earth is acceleration? When you're on Earth, acceleration due to gravity is 9.81 meters per second per second. Okay, so you would need to accelerate the book against gravity at that same rate in order to make the book go upwards. Okay, so it's quite a tricky one there, but these do come up occasionally. Okay, so that means the force is 0.2 times 9.81, which gives 1.962 newtons. I won't round that off. I'll leave that as is. I won't round till, when I say I won't round it off, I won't go to 3 significant figures yet. I'll do that at the very end. So then work is equal to the force, 1.962 times the displacement. So this book is moved 3 meters vertically. So we multiply that by 3. So the answer here, oops, accidentally opening up the TI Inspire. I don't need him for this. Okay, so I multiply my force by 3, and that gives us 5.886, which is 5.89 joules. So just a specific type of question there that may come up from time to time. If you're lifting something and they want to know how much work is done, calculate the force that would be required to overcome that gravity. And essentially it is the weight of the book or the weight of the object. Okay guys, so go ahead now and try some of these questions on work that are in the description for the video.